All right, the following heating curve is for 75 grams of substance with a molar mass of 78 grams per mole. From this data, and by reading the temperatures and heat added from the graph, calculate delta H vaporization in units of kilojoules per mole. Now, this is a heating curve, and from the lecture outlines, we know that down here is heating of a solid, and the temperature is changing for that. Here is the solid to liquid phase transition, and let's write that. Then here we have the liquid phase, here we have the liquid to gas phase transition, and then up here we have a gas. And those are the same for any heating curve. Now for this one, we're being asked to calculate delta H vaporization. That is the change in enthalpy of vaporization, meaning as we go from a liquid to a gas. And as we do that, we're going to have to know what, well, let's see, from our heating curve kinds of calculations, Q of vaporization, or Q of reaction, equals delta H vaporization times moles reacted, or in this case, moles vaporized. Now, this is a coffee cup calorimeter style equation, and we're using it for this heating curve. And we know that it's a delta H vape or delta H type or a reaction type and not a sort of temperature change one, because we can see that the temperature is not changing here. So now what we need to do is Q is our amount of heat. Our amount of heat is going to be read off of our x-axis. And this is in kilojoules, and I'm getting about, let's see, 75 kilojoules here at the end point and about 35 kilojoules here. So the amount of energy added for the vaporization was 40 kilojoules. And as you know, I'm a joule man, so I'm going to put everything in joules. That's 40,000 joules. Oh, I guess we can leave it in kilojoules because we're going to do delta H here. So let's do 40 kilojoules equals delta H vaporization times moles. Now we know we have 75 grams and we know it's 78 grams per mole, so we can find our moles vaporized there. So 75 divided by 78, 0.962 moles. So the only thing we don't know is our delta H vaporization. We can divide through, so 40 divided by 0.962, and I get 41.6 kilojoules per mole. Delta H vaporization, to turn a liquid into a gas, is always a positive number. Always check that depending upon your exact question for this homework problem. But this is a positive number, and that's what you're going to enter in.